All right. So on Friday, we talked about dilations. You guys got started with it, and we were always dilating from the origin. We had a special property that we could use there where if we knew the coordinates and we're dilating from the origin, all we do is multiply those coordinates by the scale factor, and we're good to go. But it doesn't quite work this way. In fact, none of these points, we don't even have an origin for any of these graphs that we're looking at. And so we're going to be doing these dilations. Once you understand the process for doing these dilations, it's all pretty much the same. It doesn't really get complicated, but we're going to dilate in different ways. So we're going to start by dilating where the vertex is the center of dilation. So we've got triangle ABC. We're just going to start at 1A right here. Triangle ABC, we're going to dilate that from point C. Now notice C is already one of the vertices of our triangle. That's okay, we're allowed to do that. And we have got a scale factor of 2. So I'm going to make sure that's really clear. So when it says from C right here, this is your center of dilation. It might be obvious enough to you, but just to make sure you're reading it correctly. And, of course, it says scale factor of 2. We know we're going to double all of our distances. All right, now another thing real quick I wanted to point out. It shows right here that underneath it has this notation. I'll just circle it real quick. That notation, you don't really need to worry about it, but you should be able to decipher it. Where the capital D just means we're doing a dilation. And in the subscript, it tells you C, comma 2. C is going to be your center of dilation. 2 is the scale factor. And then in parentheses, that triangle ABC says that's what we're going to be dilating. So again, not super important. Don't worry about it. I'm going to write out on your test what your dilation is. But you can also still understand that notation. All right, so if we're dilating from C, then here's one thing to keep in mind. Anytime I'm counting my movements, I'm always starting from that center of dilation. So every single time, I'm coming back to point C. So I'm going to dilate point A, first of all. And we have 2 different ways we can think about this. And you can kind of decide which way works better for you. So I've got from point C, which is my center of dilation. In fact, I'll color that red. It shows up a little bit. I colored it red. I'm going to go left 1 and up 3 to get to A. So this left 1 is kind of like a -1 movement. And this up 3 is like a positive 3. All right, so does that make sense? It's just kind of a way, it's slope in some sense. So now what I want to do is I want to double that movement. I'm starting from point C again, but now I'm going to go left, oops, not that. I want to go left 2, because that doubles it, and I want to go up, double the 3, which makes it going up 6. And I double that because that's my scale factor, 2. If it was triple, I would do 3 times it. If it was 4, then I'd do 4 times. All right, so that puts my point right here. Okay, guys. So now, I'm going to dilate point B, and we can think about this one a little differently. And you can decide, like I said, which one kind of makes more sense for you. So from C over to B, I'm going to go right. In fact, let me do this in a different color. I'll do this. Hopefully this shows up. I'm going to go right 2 and then up 1. So that's right 2, up 1. Can you guys see that blue? Okay, let me change this color real quick. I'll go with kind of a green color. Okay, so right 2, up 1. Now, I could just double that and go right 4, up 2, starting from my center of dilation. And again, I can't emphasize that enough. You always start your measurements from the center of dilation. I could just repeat this. So going right 2, up 1, and then do the same thing again. Right 2, up 1. And that gets me to the same point. So if I just want to continue that, it's like adding another drawing of the slope when you're sketching your line. So I went right 2, up 1. I'm going to go right 2, up 1 more time from point B. And I do it twice. So here's the first time, here's the second time, and there's a scale factor of 2. All right, so now what I can do is I can just take this and I can draw in the triangle. And what I'm looking for is that the triangle that I end up with looks just about the same as the one that I started with, just bigger or smaller. In this case, bigger. So as long as we're happy that we've done that, then we're good to go. Okay, I'm going to do one more, and then I'll let you guys try the other two. All right, so part B, I'm going to be dilating from D, and I'll kind of highlight that over here. I know you guys don't have highlighters, but I just highlighted point D on the graph itself. I've got a scale factor of 3 this time, so I'm going to triple my movement. So from D to F, left 1, down 2, and again, I'm thinking positive and negative movement. So negative 1 in the X direction, negative 2 in the Y direction. So now I want to triple that. I am going to go left 3 and then down 6. 1, 2, 3, 4, 5, 6. So that'll put my next point right here. And that'll be F prime. I forgot to label my points in the previous one. But this one should have been A prime. And this one over here would have been B prime. So anyways, now I've got F prime. And again, the way I can think about dilating point F, if I like this way better, is I can do this movement right 2, down 1. Or sorry, down 2. Right 2, down 2. I can do that 3 times. So there's 1, 2, 3. And I'll just kind of number those. So I can do that 3 times because it's a scale factor of 3, and then I found my point. So identify for yourself which way makes more sense, and just make it work from there. This is going to be E prime, so I'll just connect all my points together. I didn't quite go down far enough on this other one. F prime should have been right here. Hopefully you guys saw that. Okay. So does the process make sense? And I just made a mistake a second ago, so hopefully you guys didn't do the same one. But anyways, I want you guys to try problems C and D right there. And this will give you just some good practice with dilations. Okay, so I just put up the answers up here, and you can double check. So this should be D prime and F prime. Anyways, was everyone able to get those dilations done correctly? All right, now if you can do this process, it's really a lot more the same. In fact, I imagine some of you might be working ahead. That's okay. It does get a little bit complicated here in a minute, but if there's no questions, let's look at the next part down the bottom left on the page. And now we're looking at when we're dilating from the inside of a shape. So notice in the first, all the examples above, we were dilating from a vertex. So one of the points of our triangle was the center of dilation also. Now we've got a separate point, which is our center of dilation, and we're going to dilate from there. Does not really change what we do. I'm going to do 2 of these, and I'll just do it really quick. I'm not going to spend as much time with these, and you guys can do the other 2. So in problem A, G is my center of dilation. I'll go ahead and kind of underline that. So G is the center of dilation. The scale factor is 3. So from G, I know I'm going up 1, left 1 to get to A. So I'm going to triple that. Scale factor of 3. Up 3, left 3 gets me to A prime. I'm not going to keep drawing these lines. I'm doing this to really explain what the process is, but it does kind of clutter up the page for me to have this many markings. So from here, I'm just going to kind of look over, and I can see from G to B is 3 to the right. So I'm going to triple that. I'm not going to go 3. I'm going to go 3, 6, 9 to the right. It's going to end up over here. If you want to have those markings each time, that is totally fine. I'll be able to decipher it. I just don't want to clutter up the page for you guys. Okay, now from G to C is going down 2. So I'm going to triple that because, again, scale factor of 3. So now I'm going to go down 2, 4, 6. So it's going to end up at the very bottom of the graph. And there is C prime. All right, I'll just connect these together real quick. And it should look pretty close to correct. If you got a straight edge, you can make that look nice. That's just freehand sketching it up there. All right, so now I wanted to look at problem C. Jump down. Now we have one of those fractional scale factors. Actually, was everyone able to get A done? Make sense of it? Okay. Are there questions on how I got that? Okay. So I wanted to do problem C real quick, where we have the 1/2 scale factor. I'm still dilating from G, scale factor of 1/2. And now that means any movement that I have to get over to my point, I'm always counting from the center of dilation. I want to do half of that. And some of this isn't too bad. So from G over to A is up 2, and then left 1, left 2. I don't know why I keep doing that. Left 2, up 2, left 2. So where's my A prime? What do I do to get to there? There you go. Up 1, left 1. So half in each direction. There's A prime. G to C is going down 1, 2, 3, 4, 5, 6. Going down 6. So instead I'm going to go down only 3. That's half. So C prime is going to end up right there. We still good with this? All right, that means all we have left is B. This one gets a little bit weirder, but it's not that difficult. So if I count this over, I'm going to draw the line, and I'll erase it in a second. This is going to be 1, 2, 3, 4, 5, 6, 7. Oops. Plus 7, and then down 1. So I want to do half of that. What's half of 7? 3.5. 3.5. What's half of 1? 0.5. So I need to go right 3.5 and down 1/2. So I'll count that over. 1, 2, 3.5, down 1/2. It actually puts me right in the middle of this box right here. That's okay. I'm not going to give you really weird fractions that you have to put in, but half is fine. Just go kind of right in the middle. And because it's half in the x direction and in the y direction, that puts me right in the middle of the box. So there is b prime. All right, and I'll just connect these together and I'll be good to go. All right, so if that's making sense, go ahead and work on the other two for that section. You can jump ahead to the next section if you'd like. We're not going to do that as a class, but we'll move ahead in just a minute or so. Okay, so I'm not going to go through the third section when the dilation point is outside the shape. That's kind of the same thing you did on Friday, so you guys can do that. Just get some extra practice. If you haven't done that yet, you'll have time in a minute. So these problems right here, we're not going to do those now. We'll do those in a little bit. I'll let you guys. I wanted to skip to the very bottom right where our scale factor turns negative. And this actually does not affect things too much, but obviously we'll need to go through these. I'm going to do 2 of them, and then you guys will have the remainder of the class period to get the other dilations on this page finished. And, okay, let's talk about this. So we have a negative scale factor. This is totally fine. And we're going to start with a -1 scale factor. Now, if that was +1, how would that affect our shape? If we have a scale factor of just, and again, let's pretend it's just +1, does our shape get bigger, smaller? Kind of a trick question. It doesn't get bigger or smaller. A scale factor of 1, remember, you multiply by your scale factor. So like from G to B in this first problem, if I go down 1, right 1, that's -1, +1. If I multiply that times 1, then nothing changes. It's still down 1, right 1. So a scale factor of 1 doesn't change anything with our figure. Scale factor of -1, here's what we're going to do in that case. So I've already got this arrow drawn. I'm going down 1, right 1. Now I want to do the same numbers, but in the opposite direction. I'm multiplying by -1. So now my -1 in the y direction becomes a +1. All right? Now my +1 in the x direction becomes a -1. Again, you don't have to write out all these numbers when you're going through it generally. But just think, if I'm going down and right, now I want to go opposite. I want to go up and left. And because it's a -1, I'm going the same amount, just in the opposite direction. So there's going to be b prime. And all the others work the same way. So for C, to get to C from my center of dilation, I'm going up 2, right 2. A scale factor of -1 would tell me to do the same distances the opposite direction. Instead of up 2, right 2, I'm going to go down 2, left 2. So is this making sense? You can see it doesn't make it like super difficult compared to your other dilations. It's just you have to keep that in mind. Make sure you're going negative in both directions. Okay, and then for A, from the center of dilation, I'm going right 4, up 1. So opposite would be from the center of dilation, going left 4, down 1. So that's where A prime is going to end up. And if I connect that together, So, does this look familiar? How else could we get the same result? A rotation how far? 180. So this actually is a 180 degree rotation. And I want to remind you why that's the case. Remember our rotation, 180 degree rotation rule looked like this. X, y will become negative x, negative y. So all we did to get our 180 degree rotation was multiply each coordinate by -1. And that's what we're doing here. So it makes sense that a -1 dilation would be the same as a 180 degree rotation. Now, this only looks exactly the same as a 180 degree rotation when we've got a -1 scale factor. Let's do the next one, which is a -1/2 scale factor. And you can probably imagine what we're going to do here. We're still going to change our directions, but we're going to, instead of go the full distance, we're going to go half of it. So, I'll just do this one real quick. For F, and I'm looking at problem 4B right now. So H is my center of dilation. I'm going to count. I'm going left 4 here. That's -4. Well, the dilation point is going to be going to the right. I already know that. And it's going to be half of the distance. So this is going to be +2. So +2 is -1/2 of -4. All right, there's F prime. And I keep doing this, so D is up to left 2. I'm going to go down 1, right 1. Changing the distances by -1/2. Oops, that was D. Okay, and last one for E. From my center of dilation, I'm going up 2, right 4. So now I want to go down 1, left 2. That's opposite direction, 1/2 of the distance traveled. And I'll show this temporarily. I'm going to erase these lines because it looks a little messy when I do this. So this is +2, +4 to get over to E. So the way I got over to E prime was going the opposite. I went down 1, left 2. All right. So my X movement is in the opposite direction and half of what I did before. My Y movement is half of this +2 and also going in the opposite direction. So are the negative dilations making more sense? Okay. If you are good to go, you guys can keep moving. I'll finish up this dilation real quick. I'm going to get rid of those things that I added there. And then I'm going to finish drawing this. So here's the way we check it, of course, by finishing the triangle. We can see if it looks the same, just rotated 180 degrees and half the size. And it looks good to me. We'll call it good. If you have questions on what we're doing here, certainly let me know, but I'll put up an answer key for these remaining two in just a minute. And that's what you guys have about 10 minutes until it's time to get packed up. You have 6 remaining unless you've already done them, so go ahead and give that a shot. No, we're not doing that today.